Hey everyone, welcome back to my channel EduVibe. In today's lesson, we are doing the another topic of the radicals, which is the absolute value and the reciprocal functions. So absolute value is like a small topic, and we doing the absolute value functions doing this, and mainly the reciprocal part we do in the next lesson. So we are like doing the same thing in that too. So let's start with absolute values and what are the absolute values. So the two vertical bars around a number or expression are used to represent absolute value of the number or expression. For example, absolute value of x is always a positive, it written as this. Anything under the two bars like this are the absolute values. And if there is like minus 45, it not minus that if there is an absolute value, so it's be positive 45. We always the positive number we get. So that's why we use the absolute value to get the every time get that positive number. So there's 5, there's 7, and there's 323. So every time you get the positive number, even if you have like a negative in the absolute sign. So that's like the work of the absolute value, that every expression will get the positive value, positive number, or the any expression if they have to solve this, we get the positive number. Let's solve some expressions. So we have over 3 minus, and in absolute we have minus 7. So instead of 3 minus, and this will minus 7 is 7. So 3 minus 7 is minus 4. So this is firstly have to solve the absolute. So 6 minus, so 5 minus 7 is minus 2, but you get a 2. So 6 minus 4, we will get 2. So we have a minus 4, and this 2 minus 5 square will get a minus 3. Minus 3 square is 9. So 9 plus 8, here we have a minus 4, which is multiplying with that. And we have absolute. So minus 4 times 9 is minus 36 plus 8. Absolute will get minus 28, which is 28. So that's how you can solve the absolute. This is very easy topic, but we are doing the absolute functions in that because now this is like not very topic which we do like in separate video. This is like a easy topic, the absolute value, but the functions are kind of like something difficult part we get, but not very difficult, but hard to understand sometimes. So let's do absolute functions, and we have considered one function first, and we do some two in the linear and then quadratic one. So this is a function x minus 2, and gs is x minus 2 absolute. Note that gs is equal to absolute of fx. So use the values of fx to determine the values of gs and complete the table and stretch the graph. So this is like we graph to for the like a that how can we make the graphs actually. So we can do this stuff for that, but in the rest linear or quadratic function one, there is all absolute value, and we have to which thing we have to know for that. So first one we have a x minus 2. So x minus 2 is fs. So we have to make the x minus 2 graph. So we have our x values. So put the x values in and get the y values. So if we put minus 3, we get minus 5, minus 4, minus 3, we have minus 2, minus 1, 0, 1, 2, 3, and 4. We got these values. And if you put these values in the absolute one, you always get the positive value of that. So it stays the same, but should be all should be like positives one. Now you have to sketch the graph now. So we have minus 3. So we have minus 3, minus 5. We have minus 2, minus 4. We have minus 1, minus 3. Then minus 2 comma 0, because we have x minus 2 as a y-intercept. That's why it's on that y-intercept. Then you have this, 3 comma 1, 4 comma 2, 5 comma 3. Then you have a 6 comma 4. So these are straight line. This is a linear function time. And other things, we have a minus 3 comma 5. So minus 3 comma 5 over there. Then we have minus 2 comma 4. We have minus 1 comma 3, I think. Yeah, minus 1 comma 3. Then we have 0 comma 2. Then we have 1 comma 1. Then other values, 1 comma 1, we have 2 comma 0 over there. This is lie on the linear function, so it goes on like the linear function. So how can we like do that? So this is your fs graph. This is your fs graph, and we made another graph. So this one, this will be lie on that graph, like on that points, and this is your gs graph. So you can see that linear function we made, there's a straight line, and then when we made the absolute function, that will go from here, but it other like for some at some point after after 2, after s is equal to 2, they lie on the same line where the uh, linear line is going, where our original function is going. So that shows the absolute function graph. So if you have that type of graph, we have an absolute function graph. And from here, we can start thinking about the piecewise function. So piecewise function we discuss in the like next slide when we do the original thing. So that piecewise thing that we have, because we have two pieces now. We have that piece, we have full fs piece, and then we have a another piece which is lie on the linear function. So we have to mention that where they lie on the same function, same original function. So that kind of thing we have to know in that. So this is only the example type of graph. Now we're doing the absolute value of the linear function and with the quadratic function, which will get a more clarity of this thing. Consider the following absolute value, which is y is equal to 3x minus 5. So graph the function this and use the table of values of this. So y is equal to 3x minus 5, which is our original function, and absolute of 3x minus 5 is our another function. So you have to make the like these table of values again, that type of values you have to make for these twos. So I will make by my own. So let's do it in a mind, and we will do that. And if you want to make tables, so you can make this type of table of fs and gs, get the s values, put the s values and get the y values. I will do by like okay. So we have 3s minus 5. So we have some points. We start from here. We have point over there, first point. Then we have a point over there. We have a point over there. You can let put the hints. So like I put 1 and I have minus 2. That thing. So that's all you have to do. And like this. I will get that type of thing. And this is my linear graph. So let me join the list lines. And I have a minus 5 over there as my y-intercept. So it touches on minus 5. Make sure you have applied that. Another graph we have to plot, which is this one, but all values are should be now positive. So once you make the your fs values, your gs values are all the positive values of the fs values. So you can make the same thing, and at the same point, at some point, your graphs are being like attached to each other like this. Then I have over there. So this kind of thing I get. You can join this, and after this point my graph star line to that graph like this. So this is my like gs graph if I name them, and this I graph name them as fs. Make sure lines should be like all lie on that. Okay, so this kind of graph you get, and you have to be like very not points are should be priced because you get the coordinates, because you have like graph with the numbering, so you have your points should be like very accurate, and you have to find that accurate points too. And the other questions you get that determine the x-intercept if you have. So I have to determine the x-intercept by putting the y is equal to 0. Yeah, if y is equal to 0, so 3x minus 5, and you will get x is equal to 5 by 3. So we have a 5 by 3 comma 0 at subvert. So this point I think, so this point is your y-intercept, which is 5 divided by 3 comma 0. So this is your x-intercept. Another thing for your y-intercept, you have to put x is equal to 0. So y is equal to 0 minus 5. You will get minus 5, which you already plot, which you already like put in your graph like this one. So this is 0 comma minus 5. Now they mentioned we have to find we have to get state the domain and range of this absolute function. So absolute function, in that absolute function is a linear graph, so their domain goes to all the real numbers, which is that minus infinity comma infinity. For the range, you can see over there that greater than equal to 0, because you're greater but they're equal to 0. After that, the range goes to like infinity. So your range should be like greater equal to 0, and the y belongs to all the real numbers. Now the main thing, which is not like you know about this, which is the piecewise function. How can we how can we write the piecewise function? So firstly, your function, this 3s minus 5 absolute, is equal to, you put the big curly bracket or the end bracket. So firstly, you take 3s minus 5 as it is, and your piecewise function go like your first piece goes from 5, like from here they go up to that. At that point, our graph lies on the same thing, like x is greater equal to 5, 5 comma 5 divided by 3, and the other thing like this. From that, you're less than 5 by 3. If you get like minus, if you get the minus numbers, if you like go from like this thing, when you go from there, you have this kind of thing, that x is greater equal to 5 comma 5 by 3. If you have like this thing, in that date point after 5 by 3, you have a minus sign, so minus 3s plus 5. It should be plus 5. So minus 3s plus 5 is goes down over there. So that's why you have a x is less than 5 by 3, and you can't like close this bracket. This bracket stays there. So this is like your piecewise function, and that's how you have to make the graph, domain, range, essence of intercept, and that piecewise function is a very important thing to be in your, like if dimension you have to show, so you have to show. So that's all thing you have to do, and we have another graph for quadratic function now. So again, what is the function of the absolute value of minus s squared plus 2s plus 8? So actually you have to solve this thing. So you can solve this, get the answer. So you can solve this by taking the x-intercept. So take y is equal to 0. Take minus common and you get the answer, or you can factorize this. When you factorize, you get minus x plus 4 and x plus 2. So you get the two x values, 4 and the minus 2. And when you get the x is equal to 0, so this goes to 0 plus 2 times 0 plus 8, you will get 8. So make sure you have these points on your graph. So graphical shares the minus 2, graphical shares the 4, and y we have a 8 right over there. So at these points your graph must be touch, and you have to graph the function. So you again take your put your x values in this and get your y values and draw the graph. So I made the absolute like an accurate graph for this, not like wait. So let's make the graph and point somewhat. You have a 9 over there somewhere. If somewhere 9. Okay? So I put like over there and I put over there. So I put the quadratic equation like this, my original function. This time. And you have to put the arrow in this because this is the function which is going on. And after that, you have to put like you have to draw the absolute function graph, and you will see you will get some accurate points. You get some points, or you get some like very different points in your graph, and like if I plot that points, so I will get this type of graph. So if you can plot those points, you will get a graph like this. So it goes like over there like this, and over there this graph goes like this. So on the from the -2 they goes up like that, and from the 4 they goes up like that. You can see these are your function graphs. And other thing like that mentioned in that the rest of the graph is goes overlap to these point, not the arrows from the like below the x-axis, but after above the x-axis they all like lie on the same thing. So what's the domain for this kind of graph? That's why I quadratic function like this kind of thing, and you have to think more. So for the domain is always the all the real numbers in that too. So domain in quadratic one all the real numbers, and for this one this also stays the same. Everything you do in your piecewise function now. So in the piecewise function, you will get minus x squared plus 2s plus 8 absolute, which is if you take minus x squared plus 2s plus 8 as it is, your x, these are two things. Okay, your -2, your x is greater than or equal to -2, your x is greater than or equal to -2 and less than or equal to the 4. And if you take a if you take a negative thing like that, so your graph x is less than -2, but x is greater than 4. You can see over there your x is greater than 4, over there your x is less than -2, there goes less than -2. That's why we take piecewise function like that, and make sure your these lines can be mentioned in your piecewise function. These are the pieces of the function. So that's how you can do your piecewise function. They're very easy. First you have to take the original function and you take the minus of that and see that where the graph is like doing the original function of the absolute value. So that's all you have to do in the absolute values and their functions. In the next lesson, we are moving on to the absolute value equations before starting reciprocal thing. So we are doing the absolute values, and then last lesson we have a reciprocal function, which is very short lesson. So we do at the end. So that's all for this lesson. Let me see if you to vibe, learn smart but not harder. Please like, share, and subscribe to my channel. If you have any questions, let me know in the comment section. See you in the next lesson. Till let's create it with EduVibe.